Hello, in this part, we've seen how we can set up access and trunk ports, and now we'll show how we can capture traffic from access and trunk ports. Back to Genius Free, it was the topology we've got before with two switches, one trunk port that connects both switches, and then one access port for VLAN 10, one access port for VLAN 20, and in that switch, one access port for VLAN 10 and another access port for VLAN 20. Let's see the differences between the packets flowing in that cable, which is an access port, and in that cable, which is a trunk port. So right click on that cable and start capturing. Okay, from that, I will make it smaller. Here we are capturing from our trunk, for our access port, which is that one. And in the trunk port, we will start also capturing. Okay, make it smaller. Okay, here we are. We are capturing in both ports. One is the access port in VLAN 10, and the other one is the trunk port in VLAN 20. We can see the traffic in the trunk port. Why? Because we are still doing one ping in Alpine Linux 4 that belongs to the VLAN 20. So let's stop the traffic and let's send ICMP packets from the first Alpine Linux 1 to the Alpine Linux 2 in the other side. But before that, we want to filter the amount of information we are seeing here. There's lots of different packets with strange protocols. So we'll apply a filter because we only want ICMP packets. Okay. So we are selecting just ICMP packets, but those packets are not the ones we are interested in because we are seeing packets that belong to the VLAN 20. Can we filter those packets? Yeah, we could filter different ways. For example, if we are only interested in packets coming from the Alpine Linux 1, one way of filtering that will be checking which is the MAC address of the Alpine Linux 1. Okay, and checking PA, checking the MAC address. Okay, that's the MAC address of our Ethernet 0 in Ethernet 0 in the Alpine Linux 1. So let's filter that. Let's say that I want to filter packets that are ICMP and also that the Ethernet address, which it means the source and destination address, is equal to my MAC. Okay, so now there's no packet captured from that computer. Okay, let's generate traffic from the Alpine Linux 1 and we'll go on trying to ping that one to the Alpine Linux 2, which is in the other side. Okay, here in the trunk port we got traffic, and let's check in the other one. Yes, here we got also traffic, and we can also filter here ICMP packets. All the packets we have here will belong to the Alpine Linux 1, so there's no point in adding another filter. So we are seeing in both sides ICMP packets belonging to the same address. Let's stop both captures, okay? And let's go to just one packet. We want to catch one similar packet, uh, and it's an ICMP request. Okay, here let's find for an ICMP request like that. So we have two similar packets in both sides, two ACMP requests. Okay, differences between two packets. In the first part, which is the access port, we have just the Ethernet frame and the Internet protocol on top. We have in the Ethernet part the destination, the source, and the type of the packet, which is an IPv4 packet, and nothing more. Why? Because that's an access port, and traffic in access port travels untagged without no VLAN tags. That's why in that port there's no tag, but in a trunk port several VLANs could travel, so you should to add some mark, some tag, and here we are the VLAN tag. That's not in the first one, that's not in the untagged packet, that's not in the access packet, but in the trunk packet there's something added. In Ethernet we have the destination, the source, and a type saying, okay, that's not a normal Ethernet frame, that's a 802.1q virtual LAN, VLAN packet. And because it's a VLAN packet, it has some extra information. Has 1, 2, 3, and 4 new bits of information. Those 4 bits contain the following information: something about priority, something about eligibility, and then the number of the VLAN. That information is 12 bits with the number of the VLAN. That packets belong to VLAN 10. And you can see here that it's also the number A. The number OA in hexadecimal means 10. So that's the VLAN 10 marked in that trunk packet. So you can see that in a trunk cable, all the packets that travel here will carry a mark to identify the VLAN. That's what we can call that trunk cable, that trunk port, and tagged one, because the information here travels tagged with an VLAN tag, whereas the information here in an access port is untagged. And also we have been able to see how we can apply filters in Wireshark and combine different filters to get just the information we are interested in. Okay, so thanks for watching.